I'm going to run through some more examples with you guys. We'll get into some more difficult problems as we move along. So we're going to just divide by 5 on both sides. This is another simple inequality. We get x is greater than or equal to 3. Keep the word or. Subtract 1 on both sides. We get 2x is less than or equal to negative 6. Divide by 2. We're dividing by a positive on both sides, so we just keep the sign the same. This is one or the other, so it's either greater than 3, so that means a colored in dot at 3. Greater than 3 would be to the right, or less than negative 3. Less than negative 3, colored in dot, and I'd be shaded to the left. We can include some other numbers on there, like I've said, but we need to make sure we definitely include the 3 and the negative 3. The next example we have, and when I said we were going to get more difficult, all I meant was more steps in our solving of our inequalities. So we're going to add 2 on both sides. We've got 4x is greater than or equal to 16. Divide by 4 on both sides. Always paying attention to what I'm dividing by, but I am dividing by a positive. No need to flip the sign. Add 4 to both sides. Add 4 to both sides. I get 3x is less than or equal to negative 9. Again, dividing by a positive on both sides, so no need to flip the sign. We're going to put negative 3 and 4 on the number line. I'll go ahead and place 0 on the number line as well. I'm going to have, it says, I forgot my word or. So it's x is greater than 4, greater than or equal to 4, or less than or equal to negative 3. So greater than 4, or x is less than or equal to negative 3. Moving on. This one is just another one step, so I'll write through this real quick. I'll keep my or. This is the side I really want to concentrate on because a lot of you are going to lose this negative sign. If you just subtract 7 on both sides, which is what you need to do to get that 7 by itself, a lot of you want to add 7. But remember that this is what creates 0. So you get negative c is less than negative 6. This is a negative 1 out in front, so we're going to divide by a negative 1. There's that case where I have to flip the sign because I divided by a negative on both sides. So I'm ready to graph my answer. It says that I'm supposed to be less than negative 3, open dot, less than negative 3, or greater than 6. One or the other. Moving on. We're going to go ahead and say on these two, I'm going to add 1 to both sides. B, or 3b, is less than negative 6. Divide by 3 on both sides. B is less than negative 2. I didn't flip the sign because I divided by a positive on both sides. The second one, we get 4b is greater than 8. Divide by 4 on both sides. Do not flip the sign because you're dividing by a positive on both sides. Graphing my answer, I have negative 2 and 2. Open that on both of them. Has to be less than negative 2 or greater than 2. I could also put 0 on there as a reference. The next one, we want to make sure that we get rid of the positive 4 by putting negative 4 on both sides. So we get k is greater than negative 1. Or divide by negative 6 on both sides. K is less than, flip that sign, negative 5. Graphing the solution. I have negative 1 on my number line and, whoops, let's put negative 5 there. It's smaller than negative 1. We'll put negative 1 over here. Here's 0. There's negative 3 between them. We have an open dot on negative 1. It's greater than negative 1 or less than negative 5. Let's see if I can squeeze this last example in here in the time I have remaining. Plus the opposite, minus 7 on both sides. Negative 3c is greater than or equal to negative 6. Divide by negative on both sides, so I have to flip the sign. Over here I subtract 2 on both sides. I get 5c is greater than 15. Divide by 5. C is greater than or equal to 3. I don't have time to graph this.